Hello and welcome to another one of these ADD videos. We're going to look at another example of the E1 reaction, and this time we're going to look at a methyl shift. Okay, so again, the moderate to weak attacker, in this case methanol, is going to make it a 1 reaction. Heat is going to drive it to E1 reaction. Otherwise, without that heat, you'd have a combination of both SN1 and E1 reactions. So check, after you form your carbocation, check for a possible rearrangement, then abstract adjacent hydrogens, and then form your double bond. And if necessary, use Zatsev's rule. The more substituted is the more stable product. Okay, so let's look at this example here. This is again to exhibit a methyl shift. So the first step is we're going to form a carbocation. The leaving group leaves. And after it leaves a wonderful plus charge there. Oh, I've been doing rosy red, haven't I? Plus charge. And in this case, you should be able to see that if I were to take this methyl group right here and move it to the right 1 unit, what happens is the plus charge would go right here, and that carbon's tertiary as opposed to the secondary carbon we started out with. So that's what's going to happen. We're going to do a methyl shift. So the way we indicate the methyl shift is by doing the tilde sign again and writing methyl after it above the arrow, and then you write everybody down that was wrong. And the methyl group now is over here, and the carbocation now looks like this. So this is a tertiary carbocation as opposed to a secondary carbocation. Much more stable thanks to the inductive effect. So now what we do is, it's an elimination reaction. We have to abstract one of the adjacent hydrogens. It seems like one of my puppies is having a nightmare over there. Sorry about that. Okay, a little distracted. So CH3, and there's only one actually adjacent hydrogen. It's this one that's down here. Or actually, no, I'm lying to you. I'm sorry, there's 2 because these guys are adjacent to that carbocation as well. So let me draw them out. Because this bond is an alkane, it's a single bond, you can freely rotate it. So what I'm going to do is I'm going to rotate it like that. And this hydrogen that was down here is going to come up here, and the methyl that was up here is going to come down there. Okay, so if I abstract a hydrogen, I can abstract either that one or that one. Okay. Because the carbocation is right there. So it has to be adjacent to that plus sign. So when I abstract it, what's going to happen is the methanol is going to come over here and abstract one of those 2 hydrogens. Let's look at the first hydrogen, the one on the left first. And if I do that, what's going to happen is I'm going to get C with 2 hydrogens on it, and then the double bond, and then the carbon, and then we're going to have an interesting isopropyl group. Is that what it is up here? That's right there. So that one is going to have a carbon, and oh no, sorry, this is hydrogen. No, that's right. The double bond is right here. I'm going to have this whole thing be one of my things attached to the double bond. So it's ugly. That's what she got. So CH3 and there's H. And there's probably some three-dimensional geometry going on there. So the H would go into the page, and one of these would come out. So 1, 2, 3, 4. That's right. And then the bottom one would be a methyl group. Okay, so that's this group right there. That goes right there, and that goes right there. Alright, so this is dye substituted. And we're looking at the hydrogens being replaced by carbon-containing species. That's what substituting means. So this whole thing right here counts as a I made my brush way too big. It doesn't crush my system. Oh, I just crashed. That's E. So basically dye substituted means that each of these hydrogens on the other bond on the left side weren't replaced, but these hydrogens now are carbon-containing compounds. There are two of them that have been replaced, so it's dye substituted. Now let's look at the other hydrogen abstraction, the one on the right. What would happen if that occurred? So if I abstracted that one, I would have still this one intact, right? Because I didn't mess with that one in this scenario that I'm proposing. There's your double bonded carbon. And it's actually going to have a methyl group down here too, aren't you? Because this is one methyl group attached to the double bond, this would be the other one. So we would have something like that, the double bond, and after the double bond, we've taken away this hydrogen now, so we're going to have, what, two methyl groups. So this is tetra substituted. Or four substitutions, and therefore the major product according to Zatsiev's rule. And because this has less substitutions, it would be the minor product. Okay, so we covered a little example of Zatsiev's rule, and we got to do a methyl shift. Okay, recapping: methanol and heat gave us the one reaction. Leaving group left formed your carbocation. We made it into a tertiary carbocation by doing a methyl shift. Then after that, we abstracted the two adjacent hydrogens and got the two possible products, and used Zatsiev's rule to determine that this is the major product. So your answer would be that wonderful mess right there. Okay, so practice, and make sure you check out the other example videos. Thank you, and have a nice day.